right? So in my last class I have discussed about the electric field due to a line charge, right? So if we have considered a line charge along z-axis, with respect to that line charge, what is electric field at a point, right? What is electric field at a point P, that we have derived, right? And we have also done a related problem using that, right? And let me take one more related problem so that you will get even more clarity on it, right? Second problem, a line charge density of 24 nanocoulomb per meter is located in free space on the line y is equal to 1, z is equal to 2. A bit, find electric field at a point 6 minus 1 3, and B bit, what point charge Q should be located at minus 3 4 1 to cause EY bar to be equal to 0, at 6 minus 1 3, right? So this is one more important model. Okay, so no need of recording this session because I have given live YouTube live. The class is now on live, so that's why I am not recording, right? So coming to the solution, a line charge density, let me take the given data first. The given data, line charge density rho L is given 24 nanocoulomb per meter, and is located at y is equal to 1 and z is equal to 2, right? So A bit, electric field, we need to determine electric field at a point at 6 minus 1 3, right? So this is what we have done earlier problem also, same model we have done, right? So line charge is located at, let me show it. Let us say this is x, y, and z. So line charge is located at y is equal to 1. This is y is equal to 1 and z is equal to 2. right? Let us say this is Z is equal to 2, right? So that means what? The coincidence point. So this is the point, right? So this point is nothing but y is equal to 1, Z is equal to 2 point. That means what? The line is passing through this point, right? The line is passing through that point. Right? So therefore, if you draw the line is passing through this point, right? Line is passing through this point. So as I have discussed in my last class, line is passing through a point, y is equal to 1, that means y is equal to constant and z is equal to constant. It is parallel to x-axis, right? It is parallel to x-axis, right? So when the line is parallel to x-axis, it is not a function of x, right? Electric field is not a function of x. So that is very important point to be remembered here, right? So let me write here a line charge is located at y is equal to constant, z is equal to constant, and is parallel to x-axis. Then electric field at a point is not a function of x, right? Is not a function of x, right? So this is one important note to be remembered, right? A line charge is located at y is equal to constant and z is equal to constant and is parallel to x-axis. Then electric field at a point is not a function of x. Why it is not a function of x? Because I have discussed earlier that the electric field due to a line charge is perpendicular, right? Is perpendicular to the line, right? So we know that electric field due to line charge is given by E bar is equal to rho L by 2 pi epsilon naught rho A rho bar, right? So this is the electric field, expression for electric field due to a line charge, right? So A rho bar in the sense what? It is a unit vector directing normal to the line, right? A rho bar um, is a unit vector directing normal to the line, right? Directing normal to the line. So directing normal to the line in the sense what? It is electric field is normal to line in the sense electric field is along z axis or y axis, right? Electric field is along z axis or y axis. That means electric field has az bar and ay bar components, right? Electric field has ay bar and az bar come. That means electric field directs towards y axis and z axis, and no electric field exists along x axis, right? No electric field exists along x axis, right? So now in this expression, rho L is given, and we need to determine rho, right? We need to determine rho, right? So as we know that y is equal to constant, z is equal to constant. So therefore, no need to consider x component here, right? No need to consider x component here, right? Because electric field does not exist along x-axis. So therefore, no need to consider x coordinate, right? Ignore x coordinate. So therefore, rho is, let us say, rho bar, right? Rho bar is the vector distance, right? Vector distance, and is vector distance between the points minus 1 3, right? Between the points minus 1 3, minus 1 3, and the location of the point. So what is the location of the point? 1 and 2, right? 1 and 2 is the location of the point. So therefore, rho bar can be written like this. Rho bar is equal to minus 1 ay bar plus 3 minus 2 az bar, right? And this is equal to minus 2 ay bar plus az bar, right? And now rho is equal to mod rho bar, and which is equal to root over 4 plus 1, and this is equal to root 5. And similarly, arrow bar, right? Arrow bar is equal to rho bar by mod rho bar, and this is equal to minus 2 ay bar plus az bar divided by root 5, right? So we have rho, right? We have rho, scalar distance, and we have arrow bar, right? We have arrow bar. So therefore, E bar is equal to electric field at a point is equal to rho L is 24 nano, 24 nano divided by 2 pi into epsilon naught. Epsilon naught is 10 power minus 9 by 36 pi into rho. Rho is root 5 into arrow bar, right? Arrow bar is minus 2 ay bar plus az bar divided by root 5, right? So this is the electric field, and if you simplify this, right? If you simplify this, you'll get minus 172.8 ay bar plus 86.4 az bar. So this is the electric field, right? So this is electric field. So this is a bit, right? So if you observe this, so if you observe this, it is electric field is a function of ay bar and az bar, right? Electric field is a function of ay bar and az bar, right? So that means what? Electric field exists along y direction and z direction, electric field does not exist in x direction. Why? Because line charge is parallel to x-axis and is perpendicular to y and z axis. And as we know that, as now just now we have discussed that the electric field flows perpendicular, right? Perpendicular to y axis and z axis, right? So this is how we can determine electric field with respect to line charge, right? So now B bit is very important, right? So B bit is very important. You need to understand what is happening here, right? So coming to B bit, let me go back to that, right? So here in B bit, right, in B bit, what point charge here, what point charge Q should be located at -341. That means a point charge is located at -341, right? Earlier in A bit, a line charge is located, right? A line charge is located at y is equal to 1 and z is equal to 2. In B bit, right? In B bit, in addition to line charge, right? In addition to line charge, a point charge Q should be located at what? -341 to cause Ey bar to be equal to 0, right? Ey bar to be equal to 0 at 6 minus 1 3. Same point here, 6 minus 1 3, and here also 6 minus 1 3, right? So we have calculated electric field at this point, right? We have calculated electric field at this point with respect to line charge, right? So in B bit, in addition to line charge, we have also a point charge, right? We have also a point charge. A point charge is now located. Now what is electric field? So we need to determine the total electric field. Electric field at a point 6 minus 1 3 with respect to line charge as well as point charge, right? With respect to line charge as well as point charge. So now what is electric field? What is the resultant electric field? The resultant electric field is the sum of electric field due to line charge and electric field due to point charge, right? So earlier we have discussed, if the field consists n number of point charges, if the field consists n number of point charges, what is the resultant electric field? Resultant electric field is the vector sum of field due to individual point charges, right? Field due to individual point charges. Similarly, if field contains n number of line charges, so far we have discussed electric field due to one line charge. If a field consists more than one line charge, then again same, the resultant electric field is the vector sum of electric field due to individual line charges. On the other hand, if the field contains one line charge and one point charge, the total electric field is again vector sum of electric field due to line charge plus electric field due to point charge. We know how to determine electric field due to point charge, and we know how to determine electric field due to line charge, right? So in B bit, in addition to point charge, in addition to line charge, we need to determine electric field due to point charge also, right? So that is the additional factor in B bit, right? And let me explain, right? Right. So now in B bit, a point charge Q, we don't know what is Q, right? We don't know whether it is 1 millicoulomb or 2 millicoulomb or how much the value is, we don't know, right? But is located at, right? Is located at -3, 4, and 1, right? Is located at -3, 4, and 1, right? What point charge Q is to be located at -341 to cause Ey bar 2 cos Ey bar is equal to 0, right? 2 cos Ey bar is equal to 0, right? So therefore, we have determined electric field due to line charge. So this is nothing but electric field due to line charge, right? So let us say EL, right? EL bar okay, the power is gone. So due to climate change, the power has been gone. So I cannot operate my system. I only um, so my system is off, and I will be connecting in 1 or 2 minutes. Don't go anywhere. So I'm trying to connect in with my hotspot. Just a minute. Okay. Right. So I'm back again. So here electric field due to line charge is already we have determined, right? EL is equal to 172.8 AY bar plus 86.4 AZ bar, right? So this is electric field due to a line charge, right? So this is the electric field due to a line charge, which we have determined just now, right? So now electric field due to point charge, right? Let us say this is EP bar, right? EP bar is equal to Q by 4 pi epsilon naught R square AR bar, right? So this is the electric field due to a point charge, right? And what is Q here? Q we don't know, right? Q we don't know, it was not given. We have to determine Q, right? So Q we don't know, we need to determine R bar, right? What is R bar? R bar is the vector distance, right? Vector distance between -3, 4 and 1, right? -3, 4 and 1 is the it is the point where point charge is located, and at what point we need to determine 6 minus 1 3, right? So 6 minus 1 3 is the point of interest, the point where electric field is determined, right? So therefore R bar is equal to 6 minus of -3 plus 3 AX bar, right? So it is a point charge, right? So AX bar and plus -1 -4, right? -1 -4 AY bar plus 3 -1 AZ bar, right? And this is equal to 9 AX bar minus 5 AY bar plus 2 AZ bar, right? So this is R bar, right? So which is the vector distance between those 2 points, right? And R is the scalar distance which is equal to mod R bar, and which is equal to root over 9 square plus 5 square plus 2 square, right? So this is equal to root over, how much is this? Root over 110, right? And similarly AR bar is equal to R bar by mod R bar is equal to 9 AX bar minus 5 AY bar plus 2 AZ bar divided by root over 110, right? And now electric field, right? So electric field due to a point charge which is equal to Q we don't know, Q by 4 pi epsilon naught. What is epsilon naught? Epsilon naught is 10 power minus 9 by 36 pi into R square, right? R square into AR bar, 9 AX bar minus 5 AY bar plus 2 AZ bar divided by root over 110, right? So if you simplify this, right? If you simplify this, you'll get something like this. 9 into 10 power 9 into Q divided by 110 power 3 by 2, 9 AX bar minus 5 AY bar plus 2 Az bar, right? So this you will get, right? So this is the electric field, right? Electric field due to point charge, right? Electric field due to point charge, right? So now what is the total electric field here? The total electric field, right? In other words, the resultant electric field, right? Resultant electric field is equal to electric field due to line charge plus electric field due to point charge, right? Electric field due to line charge and electric field due to point charge, right? And if you add those two, right? If you add those two, you will be getting this 18 AY bar plus 86.4 AZ bar plus 9 into 10 power 9 into Q divided by 110 power 3 by 2 into 9 AX bar minus 5 AY bar plus 2 AZ bar, right? So this one, right? So this is the electric field due to line charge, and this is the electric field due to point charge, right? And we have two different expressions to determine electric field, right? Using those, we have determined electric field due to line charge and point charge, right? So now going to the problem. So what he's asking? He's asking to determine electric field, right? He's asking to determine electric field such that, right? Such that Ey to be equal to 0, right? Ey to be equal to 0, right? What point charge, right? What point charge? We need to determine point charge, right? What point charge to be located at a point to cause Ey to be equal to 0, right? Ey to be equal to 0. Ey to be equal to 0 in the sense what? Y component of electric field to be equal to 0, right? So Y component of electric field should be equal to 0. If Y component to be equal to 0, what should be Q value, right? What should be Q value? That is what he's asking, right? So therefore here, and this is very simple. Just a minute, right? Right. So Y component to be equal to 0, right? So here in line charge, what is Y component? So this is Y component, right? In line charge, this is Y component. And in point charge, what is Y component? Y component is this, right? Minus 5, including minus 5, right? So including minus 5, right? And multiplied with this one, right? So because here we have brackets, right? Here we have brackets, right? So therefore in point charge, this is Y component, right? So therefore the total Y component minus 172.5, right? And minus 5 into 9 into 10 power 9 into Q divided by 110 power 3 by 2, right? So this is the y component from line charge, and this is the y component from point charge is equal to 0, right? So this is the total Ey component, y component of electric field, right? Y component of electric field is equal to 0, right? So in this expression, only unknown parameter is Q, right? Only unknown parameter is Q. So if you determine Q value, right? If you determine Q, it will be minus 4.43 microcoulomb. You will get this. Simplify the above equation, and you will get this one, minus 4.43 microcoulomb, that you will get, right? So this is how we can do a given problem, right? So with this, we have completed line charge, and all related problems we have completed, right? And next one is surface charge, right? So point charge is over, line charge is over, and let us switch on to surface charge, right? So what is electric field due to a surface charge, right? So that we will discuss, right? And let me, as we have 15 more minutes time, let me give the introduction to this, and we will discuss the derivation in the next class, right? So let me give the electric field due to a surface charge, right? Electric field due to a surface charge, right? So electric field due to a a point charge is given by E bar is equal to Q by 4 pi epsilon naught R square A R bar. So this is the electric field due to a line charge, a point charge. Similarly, electric field due to a line charge, right? Electric field due to a line charge is given by rho L by 2 pi epsilon naught rho A rho bar, right? So these are the two important expressions we have determined. Now, electric field due to surface charge. Electric field due to a surface charge, right? Let us try to determine electric field due to a surface charge, right? So point charge, what is meant by point charge? A very small space, right, occupied by charges occupying infinitesimally small space, infinitesimally small area, that is point charge. Line charge in the sense what? Number of points, right? Number of points connected together, infinite number of points connected together, a line is formed, right? So that is the reason why, while deriving line charge, right, while deriving electric field due to line charge, we have used electric field due to point charge, right? We have used electric field due to point charge. From this expression, we have derived electric field due to line charge, right? From this expression, we have derived electric field due to line charge, because line charge is nothing but a connecting number of points, that is a line charge. Now surface. So what is surface? So here this is a surface with surface charge density rho s. So what is surface? How surface is formed? Surface is formed by joining infinite number of lines or many number of lines together, right? Joining many number of lines together, right? Many number of lines together, a surface is formed. So therefore, we use electric field due to line charge in order to derive electric field due to surface charge. So E bar is equal to rho L by 2 pi epsilon naught rho aero bar. So we use this expression and we will derive electric field due to surface charge, right? Electric field due to surface charge, right? So here, as we have royal, right? So here we have royal, right? Here we have royal. So we need to relate line charge density and surface charge density, right? We have to relate line charge density and surface charge density, right? And as we know that surface is nothing but while deriving electric field due to line charge, what we have done, we have taken a differential element, right? We have taken a differential length dz dash, right? So just remember this, right? So while deriving electric field due to line charge, we have considered a differential length dz dash. Similarly, while deriving surface charge, electric field due to surface charge, let us consider a differential width strip, right? Let us consider a differential width strip. So this is a differential width strip along y-axis. I will take along y-axis, and which is located at a point y dash. Again, that I will discuss in detail later, right? Just to find out the relationship between rho L and rho S, I am discussing this, right? So let us consider a differential width strip, right? Differential width strip, right? So differential width strip whose width is dy dash, right? Whose width is dy dash, right? So then we can write, right? We can write rho L is equal to rho S dy dash, right? So this is the relationship between rho L and rho S, right? So rho L is equal to rho S into dy dash, right? You can also verify whether it is right or wrong. You can verify, right? So for example, line charge density. Line charge density. What are the units of line charge density? Coulomb per meter, right? And surface charge density, Coulomb per meter square into dy dash. Width is meters, right? Line charge density, Coulomb per meter square. Surface charge density, Coulomb per meter square, and dy dash. Dy dash is width, right? Width in the sense meters. Therefore, meter and here meter will get cancelled, and we will get Coulomb per meter, right? Coulomb per meter, which is equal to rho L. So therefore, rho L is equal to rho S divided, right? Rho L is equal to rho S divided. So therefore, electric field will become rho S divided by 2 pi epsilon naught rho aero bar, right? So aero bar, right? And this is about the relationship between rho L and rho S, right? And now let me also discuss about the initial things here. So this is x-axis, y-axis, and z-axis, right? And let us consider a surface, infinite surface, right? So this is an infinite surface, right? So surface charge, let us consider an infinite surface charge, infinite surface charge on yz plane, right? On yz plane, right? So this is yz plane. On yz plane, I'm considering a surface charge, right? With surface charge density rho s, right? Coulomb per meter square, right? So this is the surface charge density, right? Like this, as shown in figure, right? And as I just now discussed, the surface is formed with joining lines, right? Joining lines. So therefore, let us consider a differential width strip, right? Let us consider a differential width strip. This is the differential width strip. Let us consider a differential width strip, right? At a point, so this is the point on y-axis, right? This is the point on y-axis, 0, y dash 0, right? So that means what? From here to here is y dash distance, right? From here to here is y dash distance, and let us say the width of the strip, right? The width of the strip is dy dash, right? Width of the strip is dy dash, right? And um, electric field at a point P on x-axis, right? Electric field. I will try to determine electric field at a point on x-axis, right? Therefore, electric field at a point P on x-axis can be determined from the following equation, right? From the following equation, and right, and in between this you have to write one more statement here, right? In between this, write down one more statement. Let us right. So okay, let us conclude this session here, and I will continue in the next class. So any doubts so far, you post it on the chat box. Very less number of students attended. 65 students were attended to the class, right? So thank you very much. We will continue in the next class, right? Now you can leave the class.